Hi everyone, I'm Kevin Irwin, Senior Director of Product Management at Gluware, and today I want to show you something that's going to change how you think about network state assessments. Creating pre- and post-checks or state assessments is absolutely critical for maintaining a healthy network, but let's be honest, it's also a major pain point. These checks are time-consuming to build, they require you to be a regex wizard to parse device outputs correctly, and when you're managing hundreds or thousands of devices, the sheer volume of state items you need can be overwhelming. That's where Gluware's Co-Pilot comes in. What you're looking at here is an intelligent workflow that connects you, the network engineer, with an AI agent that understands network operations. Behind the scenes, Co-Pilot leverages our MCP server architecture to securely interact with your state items, all while keeping your sensitive network data completely isolated from any AI processing. In today's demo, I'm going to walk you through a real-world scenario. We will identify a state item we need in this case, validating connected interfaces on an iOS XE router. Use natural language to have Co-Pilot build that state assessment for us. Let Gluware's validation engine verify it's correct. And here's the cool part. We can even adapt it for different vendors or operating systems. Then copy the code and save it as a reusable state item. All of this happens in minutes, not hours. Let's dive in. One of the most time-consuming parts of building network automation is creating those health check definitions, figuring out the right CLI commands, and writing regex to parse the output. What you're looking at here is how Gluware is using Model Context Protocol to let an LLM do that heavy lifting for you, directly integrated with the Gluware dial layer. So I'm going to ask something pretty straightforward. Create a state item that shows the status of connected interfaces. Now behind the scenes, the LLM has access to Gluware's schema, and knows what a valid state item looks like, what properties it needs, how commands should be structured, and the format for the regex patterns. What's happening right now is the LLM is calling Gluware's MCP tools to understand our data model. Then it's generating a properly formatted JSON object. It's choosing the right CLI command, in this case, show IP interface brief, and more importantly, it's writing the regex pattern that will parse out whether each interface is up or down. This is huge because normally you'd need to know Gluware's config model structure, test your regex patterns, deal with formatting, and if you've ever written regex for network device output, you know how finicky that can be. One wrong escape character and nothing parses correctly. The beauty here is the LLM understands both worlds. It knows how to talk to Gluware's API, and it knows network CLI output patterns. It even goes further to suggest other options related to your use case. Okay, there we go. You can see it's generated a complete state item definition. It contains our CLI command, the regular expression pattern for parsing the output, all the metadata that Gluware needs. But before I just trust this and import it, I'm going to ask it to validate that this JSON object can actually be imported into Gluware. This is where the MCP integration really shines. It's not just generating code in a vacuum. It can actually validate against Gluware's schema requirements. Okay. We see that it's called some of the tool calls, validated the summary, and even proposing some next steps. Confirms that it's valid. So now, I'm going to copy and paste this directly into Gluware's config model editor. So we'll minimize the window, go to config model editor, and we're going to add a CLI state item. We're going to name this iOS XE show connected interfaces. And we'll click on the JSON object at the bottom, paste what we had copied from the Co-Pilot window, and then click Save. And if we look what we've created, there's the CLI command it chose, there's a regex pattern. What used to take 20 to 30 minutes of documentation diving, trial and error with regex, and schema validation, it just happened in a conversation. And because it's using MCP with direct API access, this scales across all of your health check definitions, configuration templates, and whatever constructs you're building in Gluware. And there you have it. In just a few minutes, we went from identifying a network validation need to having a fully functional tested state assessment ready to deploy. No regex headaches, no hours of trial and error, no deep diving into vendor documentation. Thank you for watching, and visit Gluware.com for more.